All right. Thanks everyone for jumping on for another ATS University. We are running a series of these over the last couple of years where we do a deep dive on product or discussion on products that are specific for an application or maybe new tech and new tools that fit our spec tool in our industry. And this is one of our great deep dives into not really a new product, but a couple of new features that are available on some long-standing product that have a great foothold in the industry. My name is Zach Allison. I'm our market development manager for the ATS Spec Tool. If this is your first time jumping on to an ATS University session, we do send out a certificate of attendance to all those that join us for these sessions, so you can self-report for any of your hours. ATS is a amalgamation of brands. We're really a tech company now that takes a really a wide variety of manufacturers and their products that are focused on the plumbing and build industry. And we take all their product information, put it into an easy to use spec tool, and we try to provide great service to engineers in terms of product selection as well as product education. So that's where our ATS University stem from, is providing as much great information to the industry as possible. So one of our key brands is the Watts team. They've been with us for well over a decade now. They've got a wide variety of products, always innovating and coming up with new stuff. We did a variety of sessions with them last year on some of their new leak defense systems, some of the flood safe actions on the backflow protection line. And now there's a continuation of innovation, and we've got one of my great colleagues over there. We've worked with Drew and Brian for a number of years on kind of their engineer focus side. So Drew is going to give us a great background on corrosion protection, why you need it, why this is important, and some of the features and benefits on ArmorTech. So thanks for joining us today, Drew. Appreciate you.
Thank you. My name's Drew LaMarca. I am one of the business development managers for automatic control valves. And today we're going to talk about advanced corrosion protection for automatic control valves. This is a manufacturer specific product. So obviously I'd be talking a lot about Watts. This isn't going to be talking generic. This is more Watts specific, this lunch and learn. So, be talking about the product, the advancements of what Watts has done with corrosion protection in automatic control valves. So today, we're going to talk about ArmorTech ACVs. ArmorTech is our trade name for this advanced corrosion protection. We're going to talk a little about that for our customers. Corrosion and water distribution systems. And that's, let's just say, in the field and in buildings, because water corrosion is on everybody's radar. We're going to talk a little bit about MIC, which is microbial induced corrosion. So if you're in a fire system and you're doing an installation, and FM has done a great amount of white papers on MIC and corrosion in fire sprinkler pipes, which creates, pinholes, failures. There's been a lot of work in this area. And we'll discuss, why ArmorTech is important. AIS compliant ACVs. So when we're talking about following some of the iron and steel applications under, using federal funding. Sorry about that. You got to be AIS compliant for government funding. And we'll talk a little bit of applications. And at the end, some more advancements that we're doing with ArmorTech in double check RPZ ACVs, and we call it ArmorTech H-plate strainers. So we have like a complement of products that are out there, and again, using our advanced corrosion protection. So, it really comes down to, it's about aggressive water. And aggressive water is really the growth of microorganisms especially when you have treated water, or water that's not, let's say, flowing that fast or sitting stagnant in pipes, or it could be with low pH within the water system. These conditions create really corrosion, and this is where MIC comes from. So the way the industry is, we look at it broken up, is there's the waterworks side, which is really water main service connections, pumping stations, is stuff, let's say, before the meter. And it's operated by the municipality, or an agreement between the municipality and water utility authority. So like there's, American Water or Veolia out there. And then we have the commercial, industrial, fire and irrigation and agricultural side, which is really the connection, the private property is connected to the waterworks system. And there you got to meet, the municipality system to meet state and local codes, and be open to proper officers and employees of that municipality. So when we take a look at this, and I know a lot of people here on the commercial side, we actually look at both sides, because water is coming from the source all the way into the building. And the quality of that water doesn't change from one side to the other. What changes is really when you get into the maintenance, you get into where it impacts the end user at that faucet. And that's why it's important to really, take a look at the quality of the ACV, because really what we're trying to here is to extend the operational life, especially if it's sitting in closets or walls, and reduce maintenance cost. So ArmorTech is a disruptive technology for ductile iron ACVs. And ductile iron ACVs are the majority of automatic control valves used, mainly because of the cost of that product. So really, by putting this special micro-composite coating on it, we're really changing the industry, and we'll get into how much, different what corrosion is and how we're handling it. But basically, an automatic control valve provides pressure, flow, level, surge, and pump control in water systems. Could be in a building or out in the municipality. And the whole idea of ArmorTech, as I said before, extends the operational life and reduces the maintenance cost of that ductile iron ACV. So sometimes it gets a little confusing out there, but I like to go through this a bit. We have our Ames Fire and Waterworks ACV brand and Watts brand. And really, they're both the same. It's how the markets are used. But Ames, we do a lot of fire and waterworks applications. And really, they're focused on the municipal and fire system. And then on the other side, we have our Watts water control solutions. And these are focused on more of the private property connections from the, connected to the waterworks system. And they're, again, usually used for commercial P&H, still fire, industrial irrigation and agriculture solutions. But when it really comes down to fire protection systems, and MIC is becoming a major issue out there. So really, we focused partly on that area. And really, when you need a fire ACV, we have a great solution to that. And then two, part of it is not just saying I have a great product or out there, but we really bring it all the way through to installation. So when we now install the Armortech ACVs, we could provide installation support, service, and really technical help. Watts is the only manufacturer with an 8-year warranty against MIC on ductile iron automatic control valves. We're given 8 years out there. And that's really important because we really stand behind the product we're putting out there with this new type of coating. And we're going to get into field testing in a little bit so you could understand. But really what it helps our reps and everybody out there is it's actually a specifiable ductile iron automatic control valve for corrosion. And really, we're really upping the industry quality standards out there and creating a proprietary engineering specification that really will handle that longevity and that corrosion resistance. And again, our focus is really, as you could see, on contractors, installers, especially engineers and designers, because really your stamp, your name's going on that, and we really are sitting behind our product.
Just a quick question on that, on the warranty.
Yes, sir.
You know, we talked about the specifiable differences there, and I think the question always comes up, well, you know, what are the other manufacturers in the market doing? Do they have anything kind of similar in regards to MIC control? And I guess specifically a warranty against MIC, because I would imagine that most manufacturers just have a warranty on say parts, and it may be like 4 or 5 years typically.
No, mainly everybody has, as you said, a warranty on parts for 3 years, all the manufacturers, including us. We are the only manufacturer, though, putting an 8-year warranty against MIC on ductile iron control valves. We are the only manufacturer in the industry doing this. And you say, well, why? Because this isn't something we came up yesterday. We've been out in the field testing this for over, I'm going to say 6 years now, before we've actually introduced this into the marketplace. So we've been doing a tremendous amount of field testing. So if you take the program itself, the program is close to 8 years. Watts has been working on this to bring it to commercialization. So right now, we are the only manufacturing offering this. Any other questions? Good question.
Nothing come up yet, but I'll keep an eye on chat. If anyone does have questions, feel free to pop them into the Q&A. Otherwise, I'll pepper with questions as I always do. I'll see what we can get out of you.
No problem. So we're going to talk a little bit about corrosion to help you understand it. And, you know, corrosion from aggressive water, and that's usually typically has a low pH value. It has more total dissolved solids. The big thing is with the lower pH condition, it actually dissolves metals, you know, such as copper and lead. So that's why you see sometimes out there, all of a sudden you see a copper line getting a pinhole, and they'll say, oh, it's the, you know, it's the copper pipe, it's the manufacturer defect. Actually, it's not, it's the water. And we're going to, you know, get into that a little bit. The pH is out of the neutral range. And because of today, water, especially potable, you know, drinking water, but potable water, to get water, they're going deeper and deeper into the aquifer, and it's deeper into a limestone. So now everybody's reading about, you know, a lot of CO2 in the ground. There's CO2, you know, carbon dioxide everywhere. When that carbon dioxide reacts with the limestone, you actually get calcium carbonate, which is an acid. So it will leach metals such as copper and lead. So now you see a lot of papers even written by the EPA on high levels of copper, high levels of lead. You see Flint, Michigan. You know, where's all this coming from? It's because there's been a change in water. It's becoming more aggressive. And so, you know, I give a little analogy of, you know, you see the bluish green stain on sinks or showers, leaky faucets. blue green in the, is the color of copper oxide. And, orange brown is iron oxide. So when you see those stains, you're actually at that point leaching that copper out of the pipe into the water system. And again, corrosion can form in fire systems and treated water. Big area is MIC. This is due to the presence of microorganisms. And, these organisms are living in the piping system with the temperature, the pH level, and the amount of oxygen in the water. We'll talk a little bit later on about that. So, everybody's seen MIC. MIC is probably the most identifiable and leads into corrosion problems. So when you see the picture there of the wall of a pipe, or you might see the butterfly seat portion there, the disc, just eaten away. One of the signs I always say with MIC, because working in the fire industry and working on piping systems and taking them apart, is that rotten egg smell. And, when somebody takes the pipe apart, you go, whoa, that smells awful. And then all of a sudden that black water comes out of the sprinkler system. And, if there's a rug there, it'll stain that rug. It's nasty. And that's actually all the result of the MIC corrosion going on in the system. Also, MIC really creates an obstruction in the ACV, and which decreases its flow rate. So all of a sudden, you may size a 6-inch ACV to give you the amount of fire flow, and it's been sitting there. It may be decreasing down to 4-inch because of the amount of corrosion building up in that valve. So MIC, or the deposits in ACVs, is critical. And also, on exterior rusting and condensation does form MIC. Something, you don't see in buildings much, but outside of buildings, different in the yards, of industrial parks or commercial buildings, you do have vaults. And in those vaults, they do get flooded. And that's a lot from water chemistry, the runoff of groundwater, salt sprays, surface water submersion, splash zones, depending where you live. Everybody sees that salt going down on the ground, for ice. And then where's that all getting washed to? Sewers, driveways, everywhere. Everybody uses salt. Well, that's highly corrosive, and it gets washed somewhere. So, taking a look at it, external corrosion is a serious and could deteriorate automatic control valves. You may not get involved with it, but in certain areas, again, it may be not submerged, but it may be sitting in the soil. And there is a problem with that, especially with high salting, and they have vaults outside, and that's called hot soil. And think of it sitting, a salt enriched waters sitting with that mud or that dirt. And you see there the picture to the right. You could see the valve just from time being really all the water runoff down, into bringing not only the salt, but also all the mud from the road. And you can see it actually just fills up the vault and will cover the valve. So, one thing, again, you got the high acidity, low pH in the wet soil, and it just becomes very corrosive. So automatic control valves are used in a lot of locations. They're really everywhere. They're really efficient, low-cost valves, that don't require much maintenance if, properly sized, done, and now with the Armortech corrosion. So what is Armortech? Armortech is a microcomposite structure with superior adhesion and abrasion resistance qualities. So it could take inside of a valve, a lot of beating. It really resists corrosion penetration. So anything getting underneath epoxy, and there's actually a MIC inhibitor in it. Really, ArmorTech adds, the longevity, to the interior and exterior surface, which is coated with an NSF61 epoxy on the ductile iron control valves, which extends the operational life. Again, ArmorTech comes with an 8-year warranty, as we discussed before, on ductile iron automatic control valves. And one of the big things is the outstanding corrosion resistance in aggressive water environments. ArmorTech really, when we were looking at this many years ago, was really to stop corrosion before it starts, and that's especially MIC with the MIC inhibitor. But we've gone through extensive amount of testing per ASTM, degree of rusting, blistering, corrosion resistance, epoxy powder coating for the top coat, tested and certified to NSF 61. And we've gone through really, thousands of hours of salt spray on the exterior surface, depending on the environment. So we put a lot of testing and time into a ArmorTech automatic control valve. So after 5 years, here's a nice picture of the automatic control valve. And really, what's the characteristics? You got that really determines the corrosiveness of the environment is the pH, calcium concentration, water hardness, water temperature, dissolved solids, which we'll talk about, the oxygen, and dissolved carbon dioxide or hydrogen sulfide, in case you're working near a treatment plant. A lot of waters are being treated today, and a lot of water is actually treated and mixed with well water to create the potable water. But as everybody sees, in here's toilet to tap, they're using treated water, highly treated water, like in Arizona, for drinking. So they make it enough where they meet the potable water standards, but there's a lot of different, dissolved solid content and oxygen inside of there. So that water is not only for homeowners, it goes into buildings, it's used everywhere, but it creates more of a corrosion environment. The microbial inhibitor I talked before, it's part of that exclusive formulation that mitigates the growth of bacteria that causes MIC, which again will, you prevent that, you'll slow the corrosion down and limit that MIC from clogging or fouling downstream valves or equipment. And again, why do you need ArmorTech ACVs? One of the biggest issues is microbial action, and it's been the lead contributor, because once it starts in one area, it just grows to another, is corrosion on metals and alloys, and it could come from different areas. So it just shows you a little bit of pictures of the testing, and the top picture of an eaten away butterfly valve. So ArmorTech doesn't replace all stainless steel applications. However, both are very strong, reliable, and durable. Each has its own specific advantages for corrosion prevention. The biggest difference, though, is the cost difference between ArmorTech ductile iron and stainless steel. When it comes to ArmorTech versus the stainless steel, you got to understand your application and what the difference is, because still some people will use stainless steel in a lot of applications in buildings because they know they have a corrosive water environment, or they know you're stuck in a, let's just say, mechanical closet, and you don't want to really do any maintenance or have as least longer operational life. Well, ArmorTech allows that. Stainless steel, though, is an alloy, and it's still at least has 10% chromium in it for corrosion resistance. So Other elements such as molybdenum, nickel, and nitrogen also contribute to corrosion resistance. But one of the big issues we could offer is, the effectiveness, a cost-effective ACV combination. So we take the main valve, which is Armortech, our Armortech control valve. We use stainless steel tubing and fittings. Again, getting rid of the copper out there. We use stainless steel studs and nuts and lead-free pilot controls. So we build a very cost-effective ACV for aggressive water. Just to understand, stainless steel valves, Watts makes a line of stainless steel star ACVs with chromium, and we actually fabricate. So we get into 316 high purity. So if you're designing, a food processing plant or getting into breweries or something like that, where 316 is called out or required because of heavy food processing, we do make them. So, they do have applications out there, but they offer superior, level of corrosion resistance and, resist high pitting in high salinity environments. So 316, 304 is that, still used in a lot of factories, certain areas in hospitals, for high purity, when it's for instrumentation in different areas. So one of the things to understand when I talk salinity is really the concentration of, dissolved salts or total dissolved solids. So you say, well, where's the break, of where to use the automatic control valves? An Armortech ductile iron ACV compared to a stainless steel. So, both are used in drinking water, but, the Armortech can be used in drinking water, fresh water, because fresh water is treated to make drinking water or potable water, but we could go up even to brackish water and use a Armortech ACV, whereas before, if we took a standard ductile iron ACV, you couldn't do it before. And actually, we do have been in use in some low salinity water. So that's kind of where the break is. Whereas now stainless steel definitely used in brine water, definitely seawater you could see at the bottom, which has a very high total dissolved solids. So kind of like this explains where you'd use one to the other.
So if I'm interpreting this correctly, say most of my general use applications, whether it's call it the larger core and shell of a hospital, maybe not like the specific instrumentation area, but your general service for a hospital in most regions, most facilities, industrial office buildings, things like that, in like your downtown core is going to be more on the Armortech DI ACV side.
Yes.
And then
yes.
if we're say maybe your West Coast, right? Whether it's British Columbia in Canada, California down in the States, where you do have an amount of that seawater coming in and affecting your drinking water and your fresh water supply, that might be a situation where you're looking more towards the stainless steel.
No, you'd still probably use, because again, they're going to treat that water to get it over to the drinking water side. So you really, I'm going to say it like this is once you're converting into something where, it's going to be used even in the factory, you're really still talking the Armortech ductile iron ACV. Stainless steel really is when you start getting to some offshore or high purity 316 areas.
Right.
We're going to talk a little bit more, get into this on treated water, because treated water, or I'm going to say reuse or reclaimed water, is growing faster than to handle the potable water side. So there's a big shift in the industry and design, and we're going to talk about that. But When you get into salinity or salts, because again, everybody knows salts are very conductive, very corrosive out there. What we're showing here is really how that application, is used. So when you talk again in environments along the coastlines, um, you know, it could be from casinos to maybe a hospital. It could be high rises. Um, Ductile iron could definitely be used, whereas before, just because of the environment, that salty air environment, like taking Miami or something, they'd be putting in a lot of stainless steel because regular ductile iron would just corrode just due to the environment. So here again is something, making that break that we could do that.
Right. And then that would be a much more cost-effective method in those situations than
Absolutely.
stainless steel. Yeah. Great.
So just a little bit of ArmorTech automatic control valve summary. Obviously there's pressure reducing. You could add on different features to help work different areas. The main one for commercial is really a standard reducing valve and then one with a low flow bypass on it. But there's different control valve usages, pressure relief, altitude for water tank filling, could be for a fire tank or for a water tower, non-surge check valves used, when there's a lot of pumps involved. Solenoid control valves, very easy. We do a ductile iron, double check RPZ. And then actually we just a while ago, but we are doing safety shutoff valves for main breaks in streets or buildings, such that, if there's a water main break, the valve would shut off going into, let's say, a certain area, so you don't get contaminated water flooding, let's say, a hospital or a complex. And again, ACVs respond to pressure changes, will open, close, and modulate, and we make valves up to 24 inches. AIS ACVs, these, again, for if we're doing a government building, and part of the requirement, if you're doing a military base or you're going into different areas, even though it's commercial, it doesn't mean that to be municipal, but anytime there's government money now going out there, you have to be AIS compliant, for projects funded by the EPA and USDA and government projects. So, one of the things though is we do make AIS ACVs, but they are limited in size from 1.25 inches up to 12. They are specifiable. And again, as we showed you before, we use lead-free components, pilot components, stainless steel tubing, fittings, studs, nuts. And actually, all the valves come with a position indicator. So when the valve is open and closed, so you could see what's going on. And really, it's the protection against aggressive water. One of the features we also now have done on our ArmorTech ACVs is that we put on IoT or gauge-ready ball valves instead of standard ball valves, which allows you to later, or if you want to put on a BMS system onto the valve for pressure, if you want to monitor different things, it's a very cost-effective way because it actually, you could just screw the pressure sensor on, you could just temperature sensor, you could just really do different things, and it's already ready. You don't have to unpipe or actually even bring in a plumber. The BMS or SCADA company could come in and do the work. So really specifying ArmorTech for corrosion protection. And, the picture really just shows you what, and everybody may or may not have seen this, but, corroded valves, especially with MIC, when you're looking in, this is what it looks like. And this is definitely why there's a lot of replacement. just in drinking water systems, I think NACE, which is, the National Association of Corrosion Engineers, estimates that for drinking water systems, it's about $80 billion a year annually for replacement of corroded product. So again, we're going after reducing the spending on operation and maintenance, protecting aggressive water, extending the life of your valve or the valve in the system. And again, these are just different markets that we deal in. But one that you'll definitely see, especially on the West Coast, is really reclaimed water. It shows you there that the United States projected to increase 37% from 4.8 billion gallons per day to 6.6. What does this mean? Somebody like in Orange County, when you have processed water, you are susceptible heavy to MIC because processed water has a lower pH, more oxygen content. It may go stagnant. So a lot of usage of reclaimed water is treated. And to treat that water, it adds in the potential to have a lot more corrosion and MIC in the process. One of the things you may be working on is really we at Watts call them mega projects, but it could be large data centers, industrial centers. It could be, from battery plants to different areas. But one of the big things is the cooling. And especially now with AI, I don't know if everybody understands, but a lot of the data centers that were once put in before AI, they had a fair amount of cooling because everybody understands it gets very hot in a data center and everything. But now with AI and the chip processing speed, they have to put in even extra cooling. Well, they can't use potable water because then a municipality and city had nothing to drink because it'll all be going to there. So have moved to reclaimed water. And in Loudoun County, which is Data Center Alley right outside Washington, D.C., they process 2/3 of the internet traffic there, and 70% of the internet traffic goes through Virginia, believe it or not. They have the fiber optics running there. Outside the county, they actually built a really reclaimed or reuse water treatment plant. It's massive. And what it does is, they reclaimed all, I'm going to say, wastewaters, and that's used for cooling all these data centers. What happens, again, pH level promotes the pitting and corrosion and tubercules, which are those little tubes of MIC that form. And again, once MIC starts forming, it reduces the cooling of the system. So, and operational life of the valves. So again, data centers, huge. Everybody, again, not so much you may be doing, but a lot of power plants, electric, with coming online for EVs and charging. Well, got to have more, increasing the amount of electric on the lines, and a lot of that requires cooling. So, the more electric being used is the bigger the facility they're increasing, which means is they've got to keep on increasing the cooling to create the electric. And again, especially into industrial parks and growing out in the West, especially in the, Nevada desert, we're just bringing there Tesla, Switch, and, Google. They're putting in these new facilities, these data centers, the Amazon centers. It's all well and good, but the problem is they use a lot of water. And so what they're doing is using a lot of reclaimed water in their data centers, or even in the industrial facilities. And lastly, one of the big areas, which you may not, but is agricultural, is to really use that recycled water, because the amount of nitrogen and runoff getting into the rivers, and in this area, they could use less nitrogen, they lot less phosphorus, and they could use treated water and irrigate the crops. Let's say using a lot of different irrigation techniques, whereas before they would really have to flood. They could go to drip irrigations in different areas. So agriculture is really becoming a big use of reuse water. Going back to where a lot of factories in a lot of different areas, we call it industry, and again, a lot of it's heating and cooling with the factories, cleaning and rinsing, using a lot of reuse water. And different companies are actually putting in their own facility to use reuse water to cut their freshwater consumption or their potable water consumption down. So again, the plants, different food processing have to be designed to handle mic and heavy corrosion, because they got to reuse it. Something you may be working on is mic and fire protection systems. Again, giving you a picture of what a fire pipe with and without mic, and why it's important, because once the valve starts corroding, it may not operate, or you may not flow when it's really required. So really, it's becoming a, FM was written papers on this, that, a fire sprinkler system has to work when needed. And one of the things is sometimes the testing, they don't really test the flow as so much as the operation. Well, it might be barely operating, but you really got to make sure it's at its peak performance. Again, part of the corrosion resistance and going down the line is being used in wastewater and treatment plants. So when, you may be designing a treatment plant, or in this area. So different areas, definitely, in the buildings and shipyards, Armortech ACVs are used, is, because they offer, drip tight shutoff, no packing glands, breakaway friction, external linkages. They have the lowest operating friction. So they, something like this, it can be used anywhere in a shipyard, on the commercial, in the sense people in the buildings to outside. And lastly, one of the issues is irrigation. The corrosion, because of all the chemicals in the area, is definitely, corroding valves. When you use a lot of reclaimed water, you got to make sure it doesn't get into the potable water size. So really, we offer double check ACV assemblies in this area to make sure you don't get cross contamination into the aquifer or water supply. And just as a last product is an Armortech ACV plate strainer, which is a very low loss. So it's a better design than a Y strainer, and we provide that Armortech coating. So in closing, mic is a leading killer of valves, and we really have something here to defend against corrosion. I think the biggest thing is, Watts focuses on, certain products, but we do one thing well with these Armortech ACVs is, as I say, with Steve Jobs says, don't try to do everything and offer everything, do one thing well. And we feel that we've done it with the Armortech ACV. So I hope you got an understanding of the Armortech ACV and its capability, and describe some of its corrosion. You got a little bit better understanding of microbial induced corrosion, or MIC, and why it's important, the ArmorTech ACV and some of its applications. So just giving you a little bit of understanding here, who I am, if you want to email me or if you got any extra questions. And then lastly, definitely online, we offer a lot of continue learning with Watts.
That's fantastic. Yeah, I've done some of the Wattsworks training myself recently. It's just we've got continuing education as part of our internal kind of growth targets. So we always work towards using those Wattsworks sessions. They're great. I just did one on backflow last week. But no, that was great on the ArmorTech. It's one of those things where I'll be honest, when I first heard it, I was kind of like, you know, why are we doing an entire thing on the coding? And I think that probably a lot of people have that initial impression, but then you start to realize, you know, the thing that kind of hits home for me is when you were talking about reuse water and recycled water, because you know rainwater harvesting has become such a big thing, and using it for chillers is a prime use case. That's one of the most common use cases that I've certainly found. So having it for that, where yeah, there is going to be a lot of, as you said, aggressive water in those scenarios. It's an application that really brings home for me. So hopefully hopefully everyone on the call had a similar take home lesson at some point where you got that one piece, which is always kind of my goal, one piece of information for everyone that joins us on the call. So thank you very much, Drew. That was very interesting to me.
You're welcome. Thank you, everyone. Any questions?
Yeah, we'll pause a second for questions. I guess as always, I'll mention that you know the product that we talked about is certainly available for selection on the ATS spec tool and the Watts spec hub. So when these products are live and available in market, we always make sure that your specs and projects are kept up to date. So as soon as the new features added, we certainly have it available to be selected and added to your projects on, you know, any of the spec tools out there in the market, whether it is the Watts spec hub or the ATS spec tool. Yeah, any questions coming in from the group as we wind down here? No, I guess you covered it pretty well.
Well, if anybody has any further questions, always, you know, please feel free to contact us.
Of
and
course.
we could help
Thank
you
you
out.
very much for the information. I'm sure I'll be in contact again as I do my rounds, talking to all the various people on updating their masters for these. So I appreciate your time. Thank you very much, Drew.
You got it.
And thank you to all that joined us today. Have a great rest of the day. Bye for now.